Today we're talking about contingent valuation, or CVM for contingent valuation method. It's a way to value non-market goods, so times when we don't have a clear, well-defined market for something, but we want to know what the value is, probably for policy. So if you're evaluating two alternatives, you need to know which one's valued the most, or to do some cost-benefit analysis. So let's dig in a little bit. So there's a couple different reasons why we might want to value something called a non-market good. So whenever there's an externality, for example, when there's health impacts related to wildfire or smoke or secondhand smoke, we might want to measure those marginal environmental damages. So we need to know if this figure on the left, what I've shown is a marginal cost and marginal benefit curve intersecting. And an externality, so in this case a negative externality, raises that cost, adds that marginal environmental damages to become the social marginal cost. So we need to know how large that shift is. Alternatively, for a host of public goods, for things like open space or clean air, we need to get some measure of those preferences, some measure of those values. So public goods might not be traded in a market, so we need to get a sense. Contingent valuation methods, or CVM, is one way we might do that. In a lot of ways, CVM is probably the easiest way to measure non-market benefits. It's a process of just asking people, how much do you value it? It's a survey method. So you might go out and you ask people what's their willingness to pay or willingness to accept for whatever the issue is you're looking for. What's your willingness to pay to enter some public open space or to preserve some open space? What's your willingness to accept some increased chance of wildfire? Right? It's a directly asking, direct survey method of getting people's values. It creates a hypothetical market scenario. So when it's done well, you're trying to create this hypothetical market that can be used for a wide variety of goods and services without some sort of market equivalent. So it's especially useful when there's not some sort of closely related good or any sort of market activity that you can directly relate to the environmental product you're asked for. So there's a bunch of different ways we do this. One way is called iterative bidding. So there are different types of survey methods. Iterative bidding is the first one. And it goes something like this. So let's say the university is considering turning the land around Hughes Stadium, so the old CSU Stadium, into multi-use trails. There's a large swath of land. What are we going to do with it? So the current proposal would provide 10 miles of trails, but would raise tuition over the next 5 years by $50 per student per semester. Okay, so if this trail is created, if the system of trails is created, tuition is going to go up. Every student on campus is going to have to pay $50 more per semester set for the next 5 years. The question is, would you vote for this? Just a yes or no question, would you vote for this? Now, if you say yes, or if people say yes, then it gives this sort of starting point of this $50 is how much you would value it. What we're looking for is the maximum willingness to pay. We want to get not necessarily how much can we fleece students for, but what's that maximum value? So if they say yes to 50, we say, well, what if it was 70? Would you vote for this? What if it was 100? Would you vote for this? You kind of keep on going until people stop. So that's how you get the maximum willingness to pay through iterative bidding. So you keep upping the value. So there's another way that looks a lot like iterative bidding. It's called a payment card. And instead of asking kind of one question at a time, which is somewhat taxing maybe on the individual, you're going to do the same thing just with what's called a payment card. So a menu of choices. So in this case, I've listed $10 to $40. You just say yes or no. And presumably, if you say yes to say $20, then you would have also said yes to $10, right? So we're imposing some sort of rationality with People don't flip back and forth. You sort of say yes up until that maximum willingness to pay, and then maybe presumably no afterwards. So this is called a payment card method. It represents a menu of choices, and you circle yes or no until you reach your maximum. The third method is probably used more often these days. It's probably more aligned with kind of modern science around how we think people make decisions and avoiding some other strategic behavior that we'll talk about next. It's called dichotomous choice. So instead of asking for this menu of things, what you want is a large sample, and you ask people yes or no questions, just those two questions. So not a whole menu, but a choice of things. So for each respondent, you change that value. Would you be willing to pay $50 for this trail system? So you don't ask them like 20 different values or 5 different values. You just ask them one value, and then you move on to the next person. So you can, under dichotomous choice, so you can look at the different parts of the question. So you can change the monetary value, or you can keep the monetary value the same and say change the miles of trails. So this is dichotomous choice, and it's by far the most common one used, I would say, today. So, and you can vary those questions by a good bit. So there's the advantage of CVM is that it's relatively simple. It's easy for someone to understand what the product is. It's a survey asking people, do you value something that much, right? So are you willing to pay some level, some value for the good? There's some issues. The first one is something called hypothetical bias. So the whole point of CVM is that we're addressing an issue that doesn't exist in the market. So sometimes the scenario described is so foreign to your respondent that it's really hypothetical. And if people don't have a clear idea of what it is, and how do they come up with a clear idea of value? Also, it's a hypothetical situation you're asking. So even though I'm asking whether or not you'd be willing to pay this much for tuition, you're not really faced with the choice, right? It's still a hypothetical situation. So whether or not you're answering truthfully is a question. There's another one called starting point bias. So we saw with the iterative bidding, we started with a value, and if you said yes or no, you would go up or down depending on what you said. Well, oddly enough, that first value often is this starting point bias. So people tend to frame their decisions by that first value. So that value could be anything really, and they tend to anchor on that initial value. So the way that you would avoid that is to vary that starting point by respondent. So maybe one respondent kind of anchors on that start, but if you vary those choices or that starting point across your sample, then maybe you're better off. So something with the payment card, it does limit the choices to what's on that card. And if I'm looking at a card, let's say that I'm about an average environmentalist or an average trail user, right? I might look at that menu and I might pick something in the middle because I think that that's the average, right? I assume that if I put something on the high end of the card, then that means that I really like it. And if I put something on the low end, then that means that I don't. So we tend to form our preferences and the degree of those preferences by what's on those payment cards, right? So this is an issue in general with this, and also reflects that flavor of starting point bias. Another one is called strategic bias. So let's say that I'm not willing to pay $50 for the trail, but I think maybe I would have to pay it, but I really, really want it, right? Or I know that if I say a really, really high number, I'm not going to have to pay it, but it does reflect some strong sense of value. So that if I know that high means it's more likely to happen, the university is going to do this, I might respond strategically. It might respond in a way that reflects not necessarily what my value is, but that I really, really want it. Or if I'm really, really against it, I might just say 0. No, this is a stupid idea. I'm not willing to pay anything for this trail system. and that reflects that I don't want it. Even if I value it low, I might go the other direction to influence the outcome. Um, Generally, we can design dichotomous choice questions and experiments that are are called incentive compatible. So it's possible to design some of these things um, so that there's no reason to lie. This is called incentive compatible. So if you're really clever with the way that you design your questions and you design your survey, you're looking for something that's incentive compatible, that there's no reason to lie. And if you're doing dichotomous choice or CVM in general uh, for your environmental issue, then you should look a little bit more into all these biases. It's pretty easy to find stuff on the web related to this, and you can steer clear of at least the obvious ones. So a lot of non-market valuation, especially the CVM, came around, matured. I would say the science around it certainly matured and is really contested, I guess, as well, around the Exxon Valdez spill. So if you're not familiar with it, there was a large oil tanker that spilled just in the let's see, I guess it must be around Valdez, Alaska, and had large environmental impacts. And both sides, so the Exxon, who was responsible for the oil spill, hired economists to sort of measure the damages to figure out how much they think they should pay. And the courts as well, or the side sort of prosecuting, hired economists to argue their point. And both sides sort of tried to come up with some sort of measure of damages around this oil spill and around the birds that died and all that sort of stuff. So it's sort of the classic example. Here's a paper by Carson and others. You can look and find that. But really, non-market valuation and CVM especially really came to fruition around the Exxon Valdez spill, or rather the court case following up on it. And it looks something like this. Of course, there's a beautiful sound or beautiful kind of bay and everything else. It was just covered with oil. It was, if you were watching the news at the time, you saw pictures of birds and seals and everything just completely covered with oil and trying to deal with that. So the parts of it, so with Carson and there are others, who, again, are a really good example of how CVM should be done. The first step is to really describe the process, ideally in an unbiased way. So show pictures of things, show pictures of birds, explain the environmental damages. You want to avoid as much as the hypothetical situation as possible, right? You want to set people in this phase so they understand the environmental problem. A lot of times it's very complex issues. So you want to solve that by really describing the problem to the individuals. You can do that through a bunch of photos of the issue with maps, sort of what it looked like before and what it looked like after, for example. Okay. And then you can show the cleanup, the impact. So just really describing the process as much as possible. And then you give people choices, right? So you describe the environmental problem, and you say, how much would you be willing to pay, in this case, for example, to avoid this from happening? Here's something that's happened. There's these eagles that died. How much would you be willing to pay? And here around the Alaska, or the Exxon Valdez example, they asked this voting question. So here's the cost of cleanup. Here's the cost of preventing it from happening. Would you vote for something that bears this cost? Because everyone bears part of the cost. We're using the survey to ask people how they would vote if they had the chance to vote for the program. And again, if you can present it in an unbiased way, right? You present both sides of it. So people might say they might vote for the problem if they feel this way. People might vote against the problem if they feel this way, in a way that's ideally not demonizing them. And this is kind of what they had. They had this set of alternatives. So let's say with version A, so they did several versions of the survey. And for version A, they asked people, would you vote yes if the cost was $10? And if the person said yes, then often you would follow it up with a second one. Would you vote yes if the cost was $30? Um, and 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 let's just say that they say yes to both of those, and you're kind of done. If they say no to $10, then you might follow up with a $5 question. That's what they did here, right? So if you're not willing to pay 10, would you be willing to pay 5? And people might vote no for both of those. And you see this menu there on C. The first question would be, would you be willing to pay, or would you vote yes if the cost was 60? And if they say yes, they would bump that up to 120. If they say no, they might bump that down to 30. So that's what their sort of menu and survey approach or evaluation approach looks like. And the results look something like this, right? So they found percentages of the people that said um, yes, essentially to in question A to $10, and about 45% said yes to the $10, and yes, or rather 22% said yes to the $30. And you see this sort of distribution here down in question C. You see 21% said yes to $60. And if you get enough of these values, you can start to map out something that looks very much like the demand curve. So here we see a table of the results with the lower bound and upper bound. So about 71%, so in the middle column, that third column there, you see about 71% of the people, or it's likely that the, the the true value, the willingness to pay, is higher than 5. And you see there at 60, there's about a 37% probability that the willingness to pay is greater than 60. And for this, they found a mean willingness to pay of $97 and a median willingness to pay of $30. So that's the Exxon Valdez sort of story. Check out the paper. Maybe read up a little bit about it. I'm sure you can find something even on Wikipedia these days about this and this study. So it's a great one and a great example of contingent valuation methods. It continues to be a big part of environmental economics today.